All right. We are live. We need to do two things or three things today. Hmm. So are you able to see my screen?
Mm, yes.
Yeah. So our policy A is already trained now.
Oh,
We need to kick off the evaluation first. So let's see what's the evaluation step
okay.
over here.
Can you reload this once?
Or this Jupyter Lab.
No, no, don't reload it. Yeah, do continue, do continue, do continue.
What continue?
Yeah, click, yeah, press enter.
Yeah, I already reloaded it.
Oh, you reloaded it. Oh, yeah,
Yeah.
this is on, I think, the other one. Is it? Yes.
And then will we be able to see the video in Jupyter Lab?
No, we have to download the video. I don't know Jupyter Lab would be able to load it or render it. It's an MP4, so it's kind of a tricky question.
API? Did you change the model?
No, bro, I did not know it's over there. Yeah, it's doing its job. It's Claude.
Oh, it's running.
Mm.
Have you named your DJX Sparks?
Yes, brothers Zeus and Artemis.
Zeus and Artemis.
And Artemis has
Nice.
died. Is dead, bro. That motherfucker is dead. Yes, brother.
Pray gods.
The one of the god is down for some reason.
Mm,
Too much.
God of War reference.
Is there an option to send a message in Teams but delayed?
Yeah, you can schedule it.
Oh, damn.
Schedule the message for later. I mean, that's how it is in Slack, so I'm guessing it should be in
That should
Teams
be.
as well.
Yeah, let me just ask. Yeah. Uh, message in Teams.
Mhm.
Oh, yeah, you can. Okay, nice. Alright, we're sending on Wednesday in the morning.
Hey, my bad. Can you turn on the
No, 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 I would
DJ?
say that I would send, hey, can you take a look at this? It's not online. I don't know. Something might have happened.
He'll be like, let me check the logs.
He can check the logs, dude. Anyway, there should be only processes. And definitely, the logs will say the GPU crashed out of memory for sure, bro. GPU went out of memory because
He'll be like, what the fuck? If
who
this
runs?
is also running out of memory, I think we need one more DJ Spark.
Who runs? No, bro. He'll say, okay, bro, get more money. Then I will go to my super. Like, hey, can we get two more? That would basically like for sure, brother, for sure.
But what are you actually using DJ Spark for in your work?
So right now, like we have a diagnostic issues in our system.
Mm-hmm.
My goal is to like we have our data scattered across a lot of SharePoint files and everything. So I'm trying
Mm-hmm.
to create a unified database and a RAG model that will basically help us to look into issues or any problems that we are facing with our building automation system. That is the long-term goal. Like in a scenario where, for example, someone comes and says, "Hey, there is some kind of HVAC unit or some kind of a thing that is happening somewhere in the building," right? So the person enters the same query into the AI agent. Now the AI agents know everything about the building automation system, so they can make their
Mm-hmm.
decisions. They can make some calls to the APIs and get the data and say, "Hey, I think this might be wrong. And
Mm-hmm.
these are the steps that you can take for diagnosing these
Mm-hmm.
kind of issue." So
Mm-hmm.
basically, like the user would do the same thing, but he would have to think and brainstorm and probably go through a lot of files and everything, right? So instead of that, the AI agent take care of all these mess. So for him now to solve that kind of an issue, rather than wasting 3 or 4 days or maybe hours, he can get it done
Mm-hmm.
in like less than 30 minutes, something like that. So that in that manner, the data, like the AI models will basically help us. And the other thing is we
Mm-hmm.
need our data to stay local as much as we can. What's
I see.
yeah, what's happening with this?
It's saying still an ISAXM setup phase, GPU active at 15%, no output CSV yet expected. Once the whole evaluation completes, launch simulation context can't have code run after it exits, so there is no incremental logging, no action needed yet.
What happened?
I'm just reading the next steps.
Mm-hmm.
So next steps would be after the evaluation.
Mm-hmm.
We'll see what it outputs, and we'll also see if we need to create some other evals over there.
Mm-hmm.
Basically, what the evals are doing, how are they benchmarking this
Mm-hmm.
policy that we have trained.
Mm-hmm.
Based on that, we'll update the evals And then basically after that, we'll start a smoke test for policy B and C.
Mm-hmm.
And after that smoke test, we'll start a full training loop for B and C. For B, I think we'll add force observation, but not the penalty.
Mm-hmm.
So that will be FT force and force threshold are back in the observation size, but logs REW contact penalty is still flat and zero. For policy C, we will add the penalty but no force observation. So
Mm-hmm.
only the logs REW contact penalty thing will be in the used in the training and not the other FT force and force threshold. And then for policy D, I think all of these things that we are ignoring will be used to basically create a for policy observation. Okay, this is complete as well. Success rate 6.4%.
Dude, that it's completed already? Oh,
Yeah.
was this the training set?
This was the evaluation, bro. This is the
Oh,
eval.
oh, you have. Oh, my
This
bad.
is not the training.
What the fuck? We did like
Okay,
many.
this deterministic eval. Okay, this deterministic eval success rate 6.4%, meaningfully lower than noisy training time success rate we saw in the dashboard. That's expected actually. The point of separate eval pass training time success rate is measured under stochastic exploration policy, while this uses uh, is deterministic equal to true and is evaluated on fixed seeds rather than continuously randomized training distribution. This is trustworthy number of for results table, not training curves. Okay. Where did it write the CSV? Force spec RL results raw. What? Why? Where did it write the policy or the CSV?
Four spec RL results.
But there is no raw folder over here.
Interesting. I think that's hallucinating. Go back. Dude, go into four spec RL and then results.
There is no
Dude,
results
there is
in
results.
force spec.
Fucking, I can see the results over there. Third folder.
Oh my bad. Shit.
Yeah.
Hmm. Final insertion depth. Ooh. Peg mass.
Ah, fuck.
Are we exactly the reward function? Let's understand this. Total reward per environment per step is weighted sum of 10 named components computed in two places and added together in base terms from the upstream factor.env.get rewards not in our fork lives in our installed ISAC lab package. Plus additional terms are folks Hojini. Okay. Summation of overall components REW dict name. Key point. Mm, Seed 43 is slightly bigger than 42,
Hmm.
7.6%.
Success rate, okay.
The 1.2% gap between seed oil. Okay. So what was the result for policy 44? Okay.
What?
It's gonna record a video in Isaac Sim.
Mm.
Play. Now we are gonna use playrlgames.py.
Mm.
When we wanted to train, we were using trainrlgames.py. Hmm. Where do we see the branch in Jupyter Lab?
Branch? No, no, I don't know. There's no branching in Jupyter Lab, I guess.
But this is this branch, right? Work 26.
I don't know. You have to ask. Yeah.
Bruh. Were we able to see the video in the Git? Oh my god, bruh. Mhm. This was the course I was talking about today.
Oh.
Synthetic data generation.
Mhm.
Oh, this is how it's generating. Oh, bro, this is very important for us to read.
Oh my God.
Bro, this is how it's generating different domains, like the different mass for peg, different positions for the insertion, all that stuff. All right. Perception models and dynamic robot types. Okay, what has it done? So it's saying it has completed the video, but where logs RL? Oh, we can play in Jupyter Lab. Nice. Where is the peg?
Wait, can we ask it to give a different view? I think it can change the view of the camera.
But it will have to run the ISAXM again.
So then what we can do that. That's not a problem. How long does it take?
Mm, takes a while, like at least 5 minutes.
Because it's running it for 5 minutes, right?
For a simulation. What branch did you push?
Mission. No, the fuck.
I love Cloud Code, yeah.
My God.
It's like Jarvis. I'm waiting for all that holographic tech also, bro. Like I just wanna use my hands and not even
Would that
just my voice and my hands.
thing exist?
But it's not that good right now.
It's good. It's not that cheap. It's really good, but it's not that cheap. That's what I would say.
I don't think it exists right now.
It exists, bro. It definitely exists.
What is it called? I have never heard of it.
So you would have
Holographic tech.
like 6 or 7 motion sensors around you,
Mm-hmm.
and then just put a projector that will basically track your motions, fingers and everything,
Mm-hmm.
right? So those motion sensors cost like 10 or 20 grand. So it's like 100 or 200K setup. That's why not everyone wants
Mm-hmm.
to do that.
100 and 200, 100 or 200K setup.
Yes, bro. Those motion sensor thing, like the good ones, the good ones with the software and everything.
Mm. I'll be back 1 second. Now it updated the doc.
Mm-hmm.
1 second. Okay. So, what are you doing, bro?
Bro, just give me like five.
Okay.
Yes, sir. Where are we at?
Hmm. So we have completed this, and this was partially done, but this is done,
Mm-hmm.
and we need to write this and this.
Okay, so partially done. So what happened with the video? Did you change the view and tried it?
Yes, that's what I said over here. Look at this. Like the proper failure clip needs to be recorded. Okay. Hmm. Do you want me to merge the PR for this branch before training for policy B, C, and D, or
Yeah, we can definitely merge it before training it. Yeah, that would make sense. Yeah, we can merge it.
Hmm.
Where's my fucking phone?
Oh, fuck. Inference only evaluation hardness separate from anything logged during training loads are a game checkpoint.pth process no exploration noise training uses stochastic policy uses and the mean action and a fixed number of episodes come from the instrument.
Did you merge it?
Not yet, brother. That is still
Ah,
running.
oh, I see.
There is a 7% success rate.
Hmm.
So I think there should be like three success clips out of 30.
Hmm.
Eval system. Hmm. This is the current one, bro. Look at this.
But what the fuck are they doing, dude? Like, I'm not able. Can you zoom in?
Yeah, yeah. So this is the peg. Do you see the gray thing on the table? That is the peg. Like that is the hole, and they have the peg in their hand.
But how long is this video?
20,
Why is
13
it
seconds.
13 seconds only?
Because it's like 1, 2, 3, 4, 1, 2, 3, 4. I don't know, bro.
Dude, and can you ask it to change the angle? Because I want to see a better angle, like where I can see the robot actually doing it clearly.
I think that's where it's gonna. I don't know, bro. I can ask it.
Uh,
Right, I think we should start this now. Perception. Perception models in dynamic robotic tasks. Perception is foundational element of dynamic robotic tasks, enabling robots to operate effectively in changing and unstructured environments. Unlike traditional approaches that treated a perception as passive process, modern advancements emphasize the importance of active and task-directed perception. These methods empower robots to gather relevant information, adapt to their surroundings, and make informed decisions in real time. In this lesson, we will explore how perception models function as eyes of and understanding of a robot. These models allow robots to interpret their environment by detecting object, predicting motion, and identifying key features of anomalies. However, real-world environments often present challenges such as poor visibility, occlusions. What is occlusions?
block.
Oh, blockage. Or unpredictable changes. To overcome these obstacles, perception models must be fine-tuned for specific tasks and settings. By the end of this lesson, you will have a clear understanding of the role of perception models in robotics and how they enable robots to navigate complex environments. In the next section, we'll dive deeper into fine-tuning these models and preparing them for specific applications. Introduction to perception models. Perception models are cornerstones of robotic systems, enabling robots to interpret and understand their environment. These models process data from various sensors such as RGB camera, depth, and LiDAR, blah, 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 inertial measurement units to perform the tasks like object detection, obstacle avoidance, and object pose estimation. Input from these sensors is transformed into actionable output such as bounding boxes, segmentation masks, object poses, depth images, or information about the robot's current position. These outputs allow robots to navigate their surroundings and accomplish tasks effectively. Okay. Perception models. Okay, bounding boxes, segmentation masks, object poses, depth images, or information about the robot's current position. These outputs allow robots to navigate their surroundings and accomplish tasks effectively. Okay, object detection, the process of blah blah blah. Okay, the image segmentation. Yes, we have seen this. Object pose estimation, determining the precise position and orientation of object, enabling accurate interaction of navigation. For navigation, okay, localization, identifying the robot's exact position and orientation within its environment to support autonomous navigation and decision making. 3D scene construction, creating a detailed 3D map. Okay.
Probably backlink part.
Uh,
Mm-hmm. Yes, where we are.
Yeah. So it did find a success event, and I think it's recording the close-up shot now.
Nice.
This one. All right, let's get back to this. Key perception tasks. Object pose estimation, determining the precise position and orientation of objects, enabling accurate interaction and navigation, localization, identifying the robot's exact position and orientation within its environment to support autonomous navigation and decision making. 3D scene reconstruction, creating a detailed 3D map of the robot surrounding by combining spatial data, allowing for better environmental understanding, depth estimation, calculating the distance between the robot and object in its environment to enable spatial awareness and obstacle avoidance. Modern perception systems often integrate multiple sensors using techniques like modern perception systems often integrate multiple sensors using techniques like sensor fusion. This is important. For example, combining camera data with lidar scan can provide more comprehensive understanding of the environment, overcoming limitations like poor lighting or collisions, and machine learning further enhances perception by enabling robots to recognize patterns, predict motion, and adapt based on experience. Key takeaways: perception models can process common tasks include object detection, sensors, IMU. Okay, IMU is the new one that I've not heard about. Inertial, what is that? Inertial measurement units.
Mm.
Provides diverse inputs for perception systems, sensors, fusion technique, combine data from multiple sources for better accuracy and robustness. Machine learning enables robots to improve perception through pattern recognition and predictive analytics. In the next section, we'll explore how fine-tuning perception models can tailor them to specific robotic tasks and environments. Okay, fine-tuning perception models. What exactly are perception models and world foundational models same? Sensor data such as this ignorant useful information. For example, robots use camera image perception model. Okay, typical perception tasks include object detection, semantic segmentation, pose estimation, yes. Much richer representation of the structure and dynamism. There is a curve. It tries to capture data if the robot pushes the curve. Okay. Uh-huh. If I am training a policy on a robot. How does that connect to a WFM later? Okay, policy and a world foundational model sits at different layers, and the connection is usually through state per prediction and data generation. If you're training a robot policy today, the simplest loop is observation, policy, action, environment. For example, an ISAC lab camera joint states policy, joint tog, okay, physics simulator, next generate observation reward. Okay, the policy learns what action to take. A WFM can later be inserted to help predict what would happen if different actions were taken. Current observation, candidate action, World Foundation or predicted future state, planner, policy, chosen action. Oh, do you understand this?
Current action, sorry, observation, candidate action, wow, national. What is planner policy doing once we have the predicted future state?
Let's read the last one.
Uh-huh.
Um, One second. Okay. Policy. So imagine your trained policy is controlling a robot arm doing peg insertion normally. Policy. I see the peg here. Move 2 centimeters left. Current state. Peg is slightly misaligned. Candidate action A. Move left 2 centimeters. WFM predicts likely collision with the whole edge. Candidate action B. Rotate wrist 4 degrees, then move down. Model foundational model predicts likely successful insertion. So choose B. Okay. So basically, policy gives the options for the robot action, and world foundational models predicts if that action is going to be accurate or not.
Uh-huh.
The important thing is that world foundational models does not necessarily replace your policy. There are several ways they can work together. The first world foundational model has learned simulator instead of executing every possible action in physics or on the real robot. The model predicts future outcomes. Real sim experience, trained world foundational model, state plus action, world foundational model rollout. Okay, real sim experience, trained WFM, state plus action, world FM rollout, state T plus 1, state T plus 2. Okay, you can then train your policy partly on those imagined trajectories. Okay, this is basically the model based RL idea scaled up. Model based RL idea. Okay. The second connection is planning. Your policy might propose actions while one foundation model will evaluate possible futures, current state, action A, B, C, WFM, 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 bad future, good future, mediocre future, choose B. In this configuration, WFM is effectively giving the robot the ability to think ahead. A third connection is representation learning. Instead of feeding raw pixels directly into your policy RGB image, CNN, VIT, a policy, you might use representation learned by large world model, RGB depth history, WFM, latent world representation, policy, action. Hmm. RGB image, CNN, VIT, policy, you might use representation. Okay, that's good. Fine-tuning perception models. Pre-trained perception models provide a strong foundation for robotic application, but they often need to be fine-tuned to meet unique requirements to specific environments. For leverage robust pre-trained models instead of training from scratch. This process involves adapting the model to perform optimally in the targeted environment by using data that reflects conditions where the robot will operate. To fine-tune a model, you can collect or generate data that is representative of your deployment environment. This could include images, sensor readings, or other inputs captured in the specific setting. To fine-tune model, you can collect or generate data that is representative. Collect or generate data that is representative of your deployment environment. This could include images, sensor readings, or other inputs captured by specific testing. Alternatively, synthetic data generated in simulated environment can also be used specifically, especially when real data collection is impractical or costly. By training the pre-trained model on this tailored data set, you can improve its ability to handle complex scenarios, adapt to environmental variability, and perform tasks with greater accuracy and efficiency. Okay, for example, if a robot deployed in a warehouse with varying lighting condition and cluttered shelves, fine-tuning the perception model with the data from that warehouse will enable to detect objects more reliably and navigate more effectively. Data from that warehouse. Fine-tuning allows you to adapt pre-trained models to specific environments without starting from scratch. Data used for fine-tuning should reflect the target environment, whether collected directly or generated synthetically. Fine-tuned models improve a robot's ability to navigate complex environments and perform tasks with higher accuracy and efficiency. The synthetic data generation in simulated environments is an effective alternative, and real-world data is collection is challenging. At this point, you have learned how perception models can be fine-tuned. Okay, in this next, we'll explain on how it can be used to create data sets for and fine-tuning perception models efficiently. In this lesson, we explored the critical role of perception models in enabling robots to operate effectively in dynamic and unstructured environments. These models allow robots to interpret their surroundings, detect objects, and estimate poses and navigate through complex scenarios. What is the primary purpose of perception models in dynamic robot tasks? To control the robots, no, to interpret. Okay, said they have already answered it. Oh, okay. Which of the following is an example? Okay, which of the following is an example of the task performed by perception model? Path planning, object detection, and pose estimation? B. Why is fine-tuning a pre-trained perception model important? In 12 minutes. Need for training data set allows model adaptation models. C. Okay. What is synthetic data generation? In this lesson, we'll explore the concept of the SDG and its importance in training AI models when real-world data is limited or difficult to obtain. You'll learn how SDG creates artificial data sets that mimic real-world data, enabling the development of robust AI models. By the end of this lesson, you'll understand how to use simulation techniques to generate synthetic data and prepare it for training perception models. Define synthetic data generation and explain its role. Overcoming data scarcity, identify key techniques in SDG, including simulation-based methods and generative AI approaches. Describe how simulation environments can be used to create realistic data sets, such as those built with USD, OpenUSD certification. Recognize the benefits of using synthetic data for capturing rare event, edge cases, and diverse scenarios. Demonstrate how to design simulated environments for SDG using SimReady assets in ISAC Sim. Beautiful. Introduction to synthetic data generation. SDG is the process of creating artificial blah 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 structures, statistical attributes of the real world. This data generated using algorithm, model, and simulation is valuable when real world data is insufficient, expensive, and impractical to obtain. By augmenting real world data set with synthetic data, we can significantly increase the size and representativeness of data sets with which help the train robust models. Key technique. Simulation synthetic data is created by simulating real world environments or behaviors. This method mathematically or statistically replicates real world scenarios and is particularly effective for generating diverse data sets. In this module, we focus on simulation based SDG. Okay. Generative AI, advanced AI models to learn patterns from real data and generate synthetic data sets that closely resemble the original. An example of this has been explained in the technical blog on developing palette detection model using OpenUSD and synthetic data. Development. What is this? Palette detection. Let's see what's going on with our training.
Training or
Recording, sorry.
yeah.
What the hell, bro? It's still recording. It's close. The challenge engineers needed a way to train a machine learning model to detect densely stacked warehouse pallets for forklift manipulation without relying on expensive and time consuming manual data annotation. Okay, the solution, the team bootstrapped the project using synthetic data generation, which produces perfectly annotated training data.
Alright, dude. Uh, can you log in with
What?
the credentials for the cloud code? I think, dude, I have to use my cloud code. Like my limit has already reached, I guess, 72% for the week.
Oh,
Yeah, 70,
yeah,
76 lakh. That thing is consuming like crazy. So yeah, just
this
log.
one.
Yeah,
Yeah, okay, we are anyway done. So I'm just gonna commit it as this. I'll just push it. Let me see the video first. This is the near miss,
oh
brother.
yes, oh yes, this is what I wanted.
But
Oh
still the angle is.
damn, bro. Holy shit, we have done it. Peg
This
ins.
is the success.
Yes.
Satisfying.
Oh fucking finally. Dude, yeah, LinkedIn post incoming. We should update our GitHub repos readme as well with the
It
video.
is updated.
No, with the
Oh,
video.
with the video.
Yeah, bro.
I can do that. Where was this videos play? Where the fuck is this? Forge? Oh, logs. No, what the fuck? I'm missing the logs folder over here.
I think the logs are in Git ignored. That's why. Take a look at it.
Oh, brother. Why did you put logs in git ignore?
I didn't. Cloud Code did.
Yes, logs are in git ignore. But these are not that logs, bro.
LFS.
Mhm.
Load, we're done.
Cristiano Ronaldo is officially married, bro. Damn.
Back from where? Vacation?
Married, married.
Oh,
He's
married.
married.
I heard back. I'm like, back from where? 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 Hmm.
Okay, I've logged myself in.
Bam. Fable. Bring in the big guns.
But why?
Fable, bro. Fable. Bring. I'm just messing.
This is Sonnet, bro. Sonnet performed this.
Pegging.
Insertion.
Insertion. Peg. Insert.
You know.
Oh, fuck. Okay, so now, uh, was it like, do we need to start training the model, training our policy model?
Yeah. Yes.
Hmm.
Yes, brother. Yes. That's what I'm looking at.
But don't start the training right away, okay? Don't start the training right away.
Why?
I have some things that are downloading in the background, so building in the background. So I just want to make sure that this one also doesn't crash. The metrics looks good. We do not have any GPU utilization as of now. So yeah, I think we can start training. That won't be a problem as of now. But bro, that
Mm.
Spark is still not up. Fuck, it is dead. It's a dead beat. Let me just ping it once. No, brother. Rep. Oh,
My God, bro. Oh, my throat. So I think we'll have to keep the same number of environments across B, C, and D for a standard, like for drawing standard observation.
Mm-hmm.
512, 512, 512.
Let's see.
Bro, my brother is taking your picture on stream.
My God.
Look at this. You're making the same face right now.
CPA. Fuck.
Oh my god. Ugh. Alright, now I'm gonna merge the PR.
Okay.
Boom.
Dude, where are the videos?
I'm gonna add them now.
Oh.
But we have the first
We
results
need those
in
videos
this.
as well in our readme because that is really important.
What?
The videos.
Mm,
ask it to add it into README.
Yeah, brother. Hold on. Bro, why the fuck did it delete this document? Didn't get this document over here. Oh, I have not pulled in yet. Hmm.
You started the training of the models yet or not?
No, bro.
Oh,
I was updating the README.
okay. Peg insertion README.
Why is it not updated yet? Hmm? What the fuck? The video didn't come, bro. I don't know for what reason. They should have been here.
Uh, I think it was not linked properly, I guess. I ask Cloud Code to make sure that it is linked properly.
But I think they're not videos. I think they're GIFs that people add on the README.
No, you can definitely add videos as well. That's what I'm saying. I know they do add GIF, but okay. Or you can ask Cloud Code to convert it into a GIF as well.
That's what I was gonna do. But
If the videos are not that great, I would say. Oh, Stack Overflow, dude. Stack Overflow. It's been so long,
gone.
dude. I opened this
Huh?
site, Stack Overflow.
Nobody uses it anymore, bro.
I know, but I was the one 15 years ago.
15 years ago?
Like 15 years ago, somebody posted the same question that we had right now.
Ah. Stack Overflow also has an MCP server.
Hmm. Oh, is it? Damn.
Yeah. I might set it up in my cloud. No, bro. It's not doing what I wanted to do.
Time to pull in the big guns. Fable. Fable. Fable.
Okay, in the meantime, let's focus over here. Finally. Look at this.
Nice. Holy shit.
Nvidia, call me.
Oh my god, I'm like, fuck you, bitches.
They were like, bitches, we used to do this when you were in your liquid form.
My god. Balls. We have three contributors, but the only person that is contributing the most is Claude.
No, bro, I'm not using Claude.
Claude doesn't have public repositories. But if you're not using Claude, then you're lacking. I would just say that.
Bro, I'm saying I have that attribution thing on.
I know, but I don't give a shit about that anymore. Like it was earlier. I also have that attribution already set up in my system.
No, bro, because you were using it on what do you say, Jupyter Labs. I think that's why it is showing Claude.
Oh wait. Wait, we can take a look at the commit history, right? Let me take a look at the commit history, and then in the commit, I can see the commit message. I can see basically what is the commit message. People issues. Oh my god, peg was inserted successfully. Oh fuck, bro. Dude, how long are we streaming? Have we been streaming? Ooh,
Don't look at the time, bro. Look at the output.
my god. Yes, brother. The magic is in the cloud code. Dude, started the training.
No, bro.
Dude, start the training, dude. No.
26,809. This one. Okay. Tag insertion. Bro, do you know the price of real unpasteurized eggs?
Ten,
Real,
yeah,
organic.
$10 or $12, not more than that.
$14, brother.
$14.
For a 12 like tray.
Eight,
Like a
six, right? Yeah, I know, like 12 or 4. I said 10 or 12 because that was my max. But yeah, 14 is for New York. It's not that much.
it's very much when you eat 4 eggs a day.
But for New York, it's not that
Um,
much, I'm saying. If you're eating pasteurized, organic egg. Oh, you guys don't have Sam's or Costco, right? Oh, yes.
no. I
Yes.
think we do have Costco in New Jersey.
New Jersey. Yeah, I think it will be
But
difficult for Costco to bring in the logistics and everything.
yeah, and it won't be successful over here, bro,
No, it will
because
be
they already
successful.
have.
It will be
No,
successful.
bro, I think they're the like the local markets are more popular in New York.
No, 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 no. The thing is, it will be successful. Why? Because it will be cheaper. But usually Costco have their stores open outside of their town like that. So
Mm,
if because Costco, like, okay, let's say somebody is living next to Costco, right? They have their house over there. Why would they go to any other local shop over there to get their groceries or any day-to-day utilities or things that they're requiring, right? But now I'm not saying only for food, but there are other things as well, like getting
mm.
a bounty towel or paper towel sheet. That would be pretty cheaper in Costco, $20.
Okay, I'm running the step 8 smoke test.
Okay, yeah, here on the smoke test. Smoke test is fine. Uh,
Okay, I think we can. Well, also once we have all the policies,
mm-hmm,
we'll put this on top.
mm-hmm.
Okay, brother. Let's. Okay. So we were doing this. The challenge engineers needed a way to train a machine learning model to detect densely packed stacked warehouse pallets for forklift Manipulation without relying on expensive and time-consuming manual data annotation. The solution: the team bootstrapped this project using synthetic data generation, which produces perfectly annotated training data, bounding boxes, segmentation masks, etc., using rendered 3D environments. Starting simple, they began by rendering a basic data set of simple scenes, just one or two palettes, to train a foundational semantic segmentation model. Generative AI augmentation to improve the model's ability to generalize to the real world. They used a depth condition generative AI model to transform coarse 3D. To improve the model's ability to generalize the 3D world, they used depth condition generative AI model to transform coarse 3D rendering into more photorealistic images. Iterative data improvement: when the initial model failed to extract palettes, they iteratively improved the dataset by using USD scene construction utilities to generate thousands of diverse complex stacked palettes configurations. Evolving the task: once basic segmentation worked, they shifted to more practical tasks, detecting the center of the palette side faces where forklift inserts its forks. Okay, heat map regression. Corner detection challenges: the team went then tried detection palettes corner using heat maps, but the model struggled to infer the precise location of occluded corners due to varying palette dimensions. Vector feeder solution: to solve the occlusion issue, they placed corner heat maps with vector field approach, successfully training the model to calculate corner location based on their offset and detected face center. Final result: model was trained roughly 25,000 synthetic images and proves highly capable of detecting complex real-world palette stacks in real time on edge devices like NVIDIA Jetson AGX Orin. I need to understand what the fuck this is. I have
NVIDIA
heard a lot
Jetson
about
is
this.
their another GPU that they showcased in the keynote. Jetson Orion. It's not Orion, I guess it's Orion.
Bro, it's Orin.
Orion? My god, it's Orion. Jetson. Fuck, my system. Wait, is my system crashing? No.
I'm bold. I'm eager. I'm loving my demeanor. Okay.
Where's our benchmark? How is it
It's
doing?
running, bro.
It's running, right? I think it's doing decent. I can see the compute kicking in. 94, 93 percentage, 74, 59.
Bro, I just don't understand why we can't see this live.
What do you mean by live?
Like I want to see like a bar which says okay this much percentage completed and
You
like a
can ask it
dashboard
to
that
create a
is
bar. You can ask it to create a bar, but then you would have to run the program manually because of the CLI. Like that CLI won't allow you to see the bar. If you do it in terminal, you can definitely see the bar. It's called, I don't know what it is called, but there is something that we had for our transformers as well. There is a bar that loads.
Hmm. Okay, let's continue our Jetson Oren development kits by Jetson Oren. How much is it?
5 grand, same as DJX Spark.
Hmm. All right, synthetic data generation using simulation. Simulation-based SDG involves creating virtual replicas of physical entities or environments to produce realistic and accurate data sets. These simulations enable the generation of synthetic data for scenarios that are rare, expensive, or unsafe to replicate in real life. For example, simulations can capture edge cases like vehicle collision or extreme weather conditions for autonomous driving systems. Creating a simulated environment with OpenUSD. In this module, you will use OpenUSD to create a simulated environment with realistic assets. OpenUSD provides a powerful framework for designing 3D scenes and managing assets. Okay. The synthetic data generated, making it an ideal tool for building simulations tailored to blah 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 synthetic data sets. From these simulations will later on be used to train AI perception models. Synthetic data generation involves solves problems blah blah blah. Bro, why are they repeating everything?
They're just trying to remind us that okay, synthetic data generation solves only a certain set of problems that are limited to real world data sets.
SVG creates artificial data that replicates real-world features, structures, and statistical attributes, solving the problem of insufficient or expensive real-world data sets. Key techniques: simulation simulates real-world environments to generate diverse and realistic data sets, particularly useful for rare or unsafe scenarios. Generative AI uses advanced models to learn patterns from real data and generate synthetic data sets resembling the original. Simulation-based SDG focused on creating virtual replicas of physical entities or environments to produce accurate data sets for blah blah. Introduce OpenUSD as a framework for designing 3D scenes with realistic assets, enabling flexible and tailored synthetic data generation. Domain randomization with replicator. In this lesson, we will explore the concept of domain randomization, its significance in improving model robustness, and how to implement it using NVIDIA's replicator framework. Domain randomization works by varying scene parameters such as object appearance, scale, light. Bro, this is what we are using. Domain randomization.
Mm-hmm. With the wait, domain randomization, where is it? Okay. So
In this lesson, we will explore the concept of its significant improvement robustness, how to implement is using NVIDIA's replicator framework. Domain randomization works by varying scene parameters such as object appearance, scale, lighting, and background within a simulation environment. This variability ensures that the model learns to focus on the essential features rather than overfitting to a specific condition. Are you writing that?
no, bro. Why would I write that?
What were you doing then?
Nothing, bro. I was looking at my calendar.
Mm,
Okay,
oh, that's a good idea actually. Let me check my calendar for tomorrow.
a key factor
Good
in creating a
boy.
robust dataset for training AI models is ensuring sufficient variability in features such as textures, colors, lighting conditions, object poses, and more. Domain randomization is a systematic approach to data generation that introduces this variability during training, enabling deep learning models to generalize effectively to new and unseen environments. By exposing models to a wide range of simulated conditions, and domain randomization helps bridge and gap between simulation and real world application. Replicator, the part of NVIDIA Omniverse, offers
Omnivores.
a tool for performing the domain randomization efficiently. It supports on the fly randomization of scene attributes without requiring asset reloading, saving time and computational resources. By leveraging Replicator's capability, we can generate diverse datasets that enhance your model's ability to generalize across domains. In the next sections, you will learn how domain randomization is applied in practice and how it addresses challenge like simulation to reality or sim to real gap.
Mm-hmm. Domain randomization is a powerful technique used to generate synthetic data that mimics the variability observed by systematic randomizing on essential features of the task at hand. This approach synthetic and real-world data, enabling models trained on synthetic data to generalize effectively to real-world scenarios. Importance of domain randomization. Robust AI models capable of performing well in diverse and unpredictable environments by exposing models to a wide range of simulated variations during training. It improves their ability to generalize to unseen domains. This is particularly valuable in the field like robotics and computer vision, where collecting and annotating large-scale real-world data sets can be expensive and time-consuming. For instance, training a deep learning model to detect a cup might require thousands of images with variations in color, texture, pose, and lighting conditions. Generating this variability synthetically through domain randomization not only saves time but also ensures more comprehensive data set for training. Let's see what's going on with this.
Still running. Oh yeah, I think it's done.
Completed.
Yeah, it's done. The utilizations
For
is done.
policy B is done. Okay, policy is starting. Policy C.
So we are smoke testing all the policies at once, like.
No, only B and C right now. And then probably we'll start with policy B.
Hmm.
Also, I want to see if policy B trains faster because it will have two things extra: FT threshold and force something. What is it? Force back RL? No. Force threshold and FT force. Hmm. For instance, training deep learning model to detect cup might require thousands of images of variations of color, texture, pose, lighting conditions. Generating the variability synthetically through domain randomization not only saves time but also ensures more comprehensive data set for training. Key techniques in domain randomization: object randomization, varying the pose, scale, texture, and color of object in the scene; light randomization, altering light conditions such as intensity, time of day, and saturation; background and randomization, changing the background images or texture to introduce diversity; texture and color randomization, modifying textures and colors of objects and backgrounds to simulate real world variability. Those techniques ensure that the synthetic data sets are diverse enough for models to uh, learn robust representation that generalize well across different domains. Hmm.
Fuck. Key takeaways. Domain randomization introduces variability in simulation by randomizing parameters like lighting, textures, poses, and background. It enhances model robustness by exposing AI systems to diverse training conditions, enabling them to generalize effectively to unseen real world scenarios. Key techniques include object randomization, lighting changes, background variation, and texture modifications. In the next section, we will explore how the replicator framework can be used to perform domain randomization efficiently within the simulated environments. Interesting. Okay. Mm, 1, 2, 3. Where are we at with the?
Bro, it's gonna take time.
Yeah, bro, it takes a lot of time. Fuck.
This is why, brother, nobody else is doing it. Everybody's just assessing right now.
Because dude, that is really computer intensive. Like you need, if you're trying to do it on a scale, you need, I think, a lot of H1 rates. Introduce variability into simulation by randomizing. Okay, replicator for domain randomization. Replicator, a core extension of NVIDIA SXM, is a powerful tool designed to streamline and enhance synthetic data generation through domain randomization. It provides a flexible framework for creating and managing 3D scenes, assets, and simulations, making it an essential resource for training AI models that can generalize effectively to real world scenarios. What are the key features of Replicator? Oh my god. Domain randomization, introduce variability into simulation by randomizing object poses, scales, textures, lighting, conditions,
One
and
second.
background
One second.
environments.
Annotated images are needed. The DNN are trained in the So replicator is a framework that generates synthetic data.
Hmm.
Bro, how many documentation fucking does Nvidia have, bro? It is like an endless thing. Like I can just keep going in a fucking rabbit hole.
Each group authors.
So this is like a separate ISAC documentation over here, and the one that we are doing over here is a separate one. Getting started with ISAC documentation. What the fuck? This is crazy.
What was the start? Oh, six was still doing.
You can see it.
Oh, I can check the GPU utilization. So as soon as the GPU drops to zero, that means that the smoke test is completed.
Hmm.
So I usually take a the look at the utilization. That's the best part with the Spark, that you get dual bandwidth for CPU and GPU task.
Hmm. Writer and backends. I think this is some advanced shit.
Yes, brother. Attacher connects to the render product. After this, every orchestrator strips that render product annotator through the writer. Each annotator, you enable RGB segmentation, blah blah blah. To emit any other format, register a custom writer. See write example. Capture on play flag. Come on, dude. 49%. Fuck. Replicate shifts other built-in writer, for example, pose writer, executive object pose, and cosmos writer, multimodal data, or data cosmos time at any other format, register a custom writer. See writer example for the full list and annotators for the data source and writers can consume capture on clear flag. By default, replicator captures a frame every time. The timeline text both workflow captures data specific time points rather than continuously. So they disable the flag once. What the fuck is this?
Yeah, I don't think we'll understand this right now.
Yeah. On the fly, people perform real-time randomization without reloading or reparsing assets, significantly reducing computational overhead and speeding up data generation. Flexibility with Python API. Use built-in randomizers or create custom scripts for tailored randomization needs. By exploring deep learning models to these randomized datasets during training, the replicator help bridge the gap between simulation and reality, ensuring robust,
Where are you reading?
like by exposing like the last second line.
Oh,
Yeah.
wait. On the fly randomization perform real time randomization without reloading or reparsing assets, significantly reducing. How does on the fly randomization save compute?
Uh, because it's not
Without
recording or
reloading or
reparsing
reparsing assets.
assets, right? That's why.
reducing computational overhead and speeding up data generation.
So it's basically randomizing based on the current assets that are already pre-rendered. That's the trick that they are doing for on-fly randomization. Like it's like scene loading. Every time you are trying to change the assets opinions of the asset, they're gonna recompose. But on the fly won't recompose those assets. And you can basically change the values without rendering them, I guess. Dude, smoke test are also taking so long. DJX Spark is also not good for this thing, I guess. We need a bigger machine.
Time to convince them to get the big guns.
No, bro. To convince them to get those big guns, I have to make something like crazy AF. That, to get those big guns, it's not gonna be that easy.
Mm,
Oh, it's done. It's done. The utilization just went to zero. So it's completed.
yes. Mm.
Alright, bro. Are we starting the test? Panel one.
I think so. This says the step 9 should be to confirm if policy D is also ready. Did it get the video? Dogs, games, for
Yeah, 16 minutes ago. Dude,
the
there is only
policy.
checkpoints.
What? Nothing. Nothing. Let me continue to step 9 and then we can commit this work and start the training.
Mm-hmm.
Call it a day.
Oh, you're gonna do the smoke test on policy D as well.
Yeah, no, I don't think that's a smoke test. It's just it's checking if everything is present on like all the parameters are present for. Yeah, see, it was very quick.
Nice. Start the training.
Wait, yes. I will push this and I'll pull it over here, and then I'll ask what are the next 10 steps, and then
Mhm.
I'll start the training.
What is it doing?
Oh, this one?
No, no, the our training thing.
Done.
Yeah. Sync changes. Okay, let's start it.
Wait, it had a 12 one also? Oh, it already wrote this. Damn. Okay. Is Kit running somewhere on your DJX Spark?
No, it's not running right now.
It's saying it's under pressure, bro.
Oh, I think there is a VLLM process running. It's fine, but the RAM is under 99 GB. Holy shit! Wait. Hold off, hold off, hold off. Wait, what the fuck? Oh damn! It's 107 gigs. Okay, give me a minute.
Bro, what the fuck are you running?
I'm loading a VLLM.
Why are you doing everything all at once?
I was a dude. I was trying. It was not using any GPU, so I was like, okay, that's fine. I didn't know that RAM shot up like crazy.
Why would it not use VLLM, bro?
What?
Why would it not use GPU? Like,
It's
if
not
it's
using.
in
It was not because it was like setting up everything. I think it's right now loading tensors, and those tensors are pretty heavy.
one button and your second DJX Spark will also go down,
Yes,
brother.
brother. It will say, brother, I think Lord have some mercy on us, and then it will die. And then in the morning, I will text, hi, brother. And the next spark is boom, boom. There was a fire, a small incident, and then,
Oh, I thought I was working on my DJX Spark that I have at
my
home,
God,
but accidentally I was logged into your DJX
my
Spark.
Lord is gone. It's gone. It's smoked up.
The game is gone.
Free gig available 21 gig swap. Oh, dude, the swap is fully maxed out. I need to increase the swap anyways. What should be very swapping is concerning the part of a neurons with short-term risk and photograph capture finish. Okay. Holy shit, dude. Yeah, bro. I think I would have to kill the process out. It's giving me warning that if it keeps going like this, oh, it's up. But why the fuck is it taking so much VRAM? I cannot have so much VRAM in use.
Brother, kill it.
Stop it. Release VRAM and increase the swap size to max. Yeah, it's going down. Yeah, there we go. Damn. Bam. Yeah, you can start it up.
I'll do wait and recheck.
Yeah. Dude, but holy shit. It went like 110 gigs. Yeah, this is not like doable for at any point. Wait, can you stop? Can you hold on a minute for before starting up? Because I am increasing the memory swap to like 128 gig so that we can
Mm.
have more buffer.
It's saying GPU is now clear.
Yes. Yes, brother. We have now 250 gigabits of memory available. Just
So
increase.
should I continue or pause it?
Yeah, continue, continue. It's done. What?
Oh, the other one came up.
What?
The other one also came up.
No, no, no. My robot started cleaning up.
Uh,
What is the max swap? Okay, bro. Is your I think the trading has started, right?
Started successfully.
Okay. Yeah, make sure it's on no hop.
Yeah, it is on no hop. It said
No
no
hop.
hop.
Yeah,
Look at
yeah,
this.
that's perfect.
Manual no hop.
All right. I would say just keep the logs offline until like we get our other DJ Spark online.
Like the what logs?
Like this report, keep it offline. Do not publish it for now. Like until 20, until like tomorrow 12. I will publish it.
Okay, so I won't do it.
Yeah, just ask. Keep logging it. We need the logs anyways for our personal data.
Mm-hmm.
We need the logs. Cause I don't know. I don't know. Like if that guy takes a look at it, the DJ Spark. I don't want to be like, hey, why are we publishing data continuously? So
Okay, so it has started.
all right.
Do you want to continue this?
No, bro, let's end the stream. It's already 3, bro.
Okay, so tomorrow we'll do this
Mm-hmm.
because I don't think we'll be like the training would be completed by tomorrow.
Yeah, it won't be.
So we'll do this. I don't know what this is. This is how synthetic data generation works.
Dude, that cable comes in right. Dude, if the cable comes in right, there would be more memory for me. I can push harder. I can push harder.
Oh, I think now I understand what Sporsha did.
Alright, bro.
Bro, but let's decide how do we want to do this tomorrow? Because music,
What is it on?
what?
It's on ISXM, right?
Yeah.
Yeah, then we can do it on ISXM. That's not a problem. Because tomorrow, hopefully, the other one would be up, and then we can use that one for that.
Okay.
Because on one of them, the training is going on, right? So we cannot.
Mm-hmm.
So that's how we will go with it.
Okay. I see. Let me end the stream now.
Okay.
Hmm. Okay.
चलो ठीक है फिर